Section 1D, The Edge of Space, 1.20, The Final Frontier. The United States space program originated from the seminal experiments of American engineer Robert H. Goddard, whose ideas and early designs were further refined by the rocketry advancements of Nazi Germany. In 1944, after 8 years of research, German scientists successfully launched the world's first intermediate-range ballistic missile, the V-2 rocket. This nascent threat of attack from hundreds of miles away made it clear that future warfare would not be limited to only land, sea, and sky. At the conclusion of World War II, almost 1,600 of the Nazis' leading scientists, engineers, and technicians, under the direction of German scientist Werner von Braun, surrendered to Allied forces and were secretly moved to the United States. During the ensuing of the Cold War with the Soviet Union, they continued their groundbreaking work throughout the 1950s under the supervision of the United States Army, eventually laying the foundation for American ballistic missile technology, satellite development, and later, manned space missions. Following the war, Major General Curtis E. LeMay, then Deputy Chief of the Air Staff for Research and Development, envisioned space operations to be an extension of air operations. In 1946, he tasked the Research and Development Corporation to propose a preliminary design for an experimental world-circling spaceship, what would later be known as satellites. In late 1953, the Assistant Secretary of the Air Force for Research and Development convened a group of experts known as the Strategic Missiles Evaluation Group, codenamed the Teapot Committee, to examine the field of long-range missiles and accelerate intercontinental ballistic missile development. Based on the committee's recommendations, Air Research and Development Command established the Western Development Division to develop and field test intercontinental ballistic missiles. On 2 August 1954, Brigadier General Bernard Shriver assumed command of the new organization. 1.21, The Space Race. While the focus of the late 1940s was the pursuit of rocket research and upper atmospheric sciences as a means of assuring American leadership in technology, a major step forward came when President Dwight D. Eisenhower approved a plan to orbit a scientific satellite as part of the International Geophysical Year, IGY. IGY was a cooperative effort to gather scientific data about the Earth for the period of 1 July 1957 to 31 December 1958. On 4 October 1957, the Soviet Union successfully launched the Sputnik 1 satellite into Earth orbit. The Soviet success marked the beginning of the space age and sparked the space race between the United States and the Soviet Union. In response to the Sputnik 1 launch, President Dwight D. Eisenhower accelerated civil and military space efforts, a decision that would prove crucial throughout the Cold War. To counter the threat of a possible Soviet nuclear attack, President Eisenhower made development of an intercontinental ballistic missile, ICBM, a national priority. By the end of the decade, the Air Force accepted its first long-range Atlas ICBM, followed later by the Titan system. In 1958, the Air Force developed plans for a manned military presence in space, but President Eisenhower reserved manned missions for the National Aeronautics and Space Agency, NASA. However, the Air Force's plan formed the basis of the Mercury, Gemini, and Apollo programs. The Space Transportation System, commonly known as the Space Shuttle, was born out of a desire by NASA to ferry astronauts to large space stations, and a desire of the Air Force to put military astronauts into space. 1.22, Maximizing space effects. Concurrent with efforts to develop long-range missiles, the United States pursued space-based technology to reveal credible information on Soviet military intentions and capabilities. Following the recommendation of the Research and Development Corporation's Project Feedback Report, senior Air Force leaders issued Weapon System Requirement No. 5, directing the development of an electro-optical reconnaissance satellite. This new era of space-based platforms was eventually broadened to include other missions such as missile warning, space awareness, and battlespace characterization. To support these new technologies, the Air Force developed the ground-based infrastructure to support, augment, and complement the space-based portions of satellite systems. Ground-based systems included the Ballistic Missile Early Warning System, Space Object Surveillance, and the Air Force Satellite Control Network. In addition, the Air Force developed launch ranges necessary to get satellites into space, one at Cape Canaveral, Florida, and the other at Vandenberg Air Force Base, California. These launch bases provide support not only for Department of Defense-sponsored systems, but also for the NASA, other U.S. government agencies, and additional commercial enterprises. 1.23 Space Reconnaissance. In 1960, the National Reconnaissance Office was formed to take charge of highly classified reconnaissance satellites. President Eisenhower undertook several initiatives to help prevent a surprise nuclear attack against the United States, including establishing the Classified Satellite Photo Reconnaissance Program, codenamed Corona. This system, known publicly as the Discoverer Research Program, achieved its first successful launch of the Discoverer 13 on 10 August 1960. This early success acquired over 3,000 feet of reconnaissance film from space, heralding the beginning of America's space-based photo reconnaissance capability. The Air Force concentrated on unmanned missions to fulfill national security needs. Space reconnaissance satellites, for instance, supported strategic deterrence throughout the Cold War, providing invaluable knowledge of the Soviet Union's nuclear inventory and verifying compliance with weapons control treaties. Space systems provided early warning of ballistic missile attack on North America and set the stage for worldwide communications platforms for strategic command and control. Intelligence collected from space remains essential to United States national security. It is foundational to the formulation of foreign and defense policies, the capacity of the President to manage crisis and conflicts, the conduct of military operations, and the development of military capabilities to assure the attainment of United States objectives. In the early 1990s, space came out of the black world of secrecy and into the mainstream military during the Gulf War. Warfighters in the Gulf, soldiers in the foxholes, cargo aircraft flying people and equipment, and ships at sea gained greater access to space-based information. This information helped military planners see what Saddam Hussein could not see, and gave coalition forces the high ground to drive Iraqi forces from Kuwait. 1.24 Global reliance on space capabilities. Space-based technology revolutionized major aspects of commercial and social activity, and will continue to do so as the capacity and capabilities of satellites increase through emerging technologies. Space enters homes, businesses, schools, hospitals, and government offices through its applications for transportation, health, the environment, telecommunications, education, commerce, agriculture, and energy. Much like highways and airways, water lines and electric grids, services supplied from space are already an important part of the United States and global infrastructures. Commercial space activity has become increasingly important to the global economy. Civil activity now involves more nations, international consortia, and non-state actors. Space-related capabilities help national leaders to implement American foreign policy and, when necessary, to use military power in ways never before possible. Because of space capabilities, the United States is better able to sustain and extend deterrence to its allies and friends in our highly complex international environment. In the year 2000, the United States recognized the increasing importance of Global Positioning System, GPS, to civil and commercial users by discontinuing the deliberate degradation of accuracy for non-military signals, known as selective availability. Since that time, commercial and civil applications of GPS have continued to multiply, and its importance has increased significantly. GPS is now a key component of the United States critical infrastructure. Services that depend on GPS are now an engine for economic growth and improved public safety. 1.25 Space Commission. In January 2001, a commission headed by then United States Defense Secretary-designate Donald Rumsfeld warned about a possible space Pearl Harbor in which a potential enemy would launch a surprise attack against United States-based military space assets, disabling them. The commission warned, the United States is more dependent on space than any other nation, yet the threat to the United States and its allies in and from space does not command the attention it merits. Recognizing the importance of space to United States national interests, Congress chartered a review of national security space activities, released in May 2001. the report of the Commission to Assess United States National Security, Space Management and Organization, better known as the Space Commission Report, found that the security and economic well-being of the United States and its allies and friends depend on the nation's ability to operate successfully in space. To be able to contribute to peace and stability in a distinctly different, but still dangerous and complex global environment, the United States needs to remain at the forefront in space, technologically and operationally, as we have in the air, on land, and at sea. Specifically, the United States must have the capability to use space as an integral part of its ability to manage crises, deter conflicts, and if deterrence fails, to prevail in conflict. 1.26 The ultimate high ground. Over the last decade, space has become competitive, congested, and contested. The opportunity to achieve and hold the high ground advantage in space is no longer limited to the United States. Many countries either conduct or participate in space programs dedicated to a variety of tasks, including communications and remote sensing. The United States will continue to be tested over time by competing programs or attempts to restrict United States space activities. On 11 January 2007, the world received a wake-up call when China conducted its first successful direct ascent anti-satellite (ASAT) test by destroying one of its own satellites. While there are long-term political and strategic implications to this test, the immediate result of the test was that it created a debris cloud estimated at 950 pieces, 4 inches or bigger, plus thousands of smaller pieces. Satellites in low Earth orbit such as reconnaissance and weather satellites and manned space missions, including the International Space Station, Space Shuttle, and China's manned flights, became vulnerable to the increase in space debris resulting from China's satellite destruction. This space debris increased the collision risk for about 700 spacecraft. Due to the technical nature of space operations, the broadening diversity of threats and the complexity of the future battlespace and the development of space systems operations, it is essential to maintain superiority in the space domain. The space domain and the vertical environment is increasingly saturated with near-space peers. Our ability to operate freely through space, recognize when fighting extends to space, exploit space-based effects at a time and tempo of our choosing, and dictate the parameters of space access are all challenged. 1.27 The Space Imperative. Throughout our space history, the regime above our atmosphere has been viewed as a peaceful, benign, and utilitarian environment, shared beneficially among all mankind. However, space has also been a direct contributor to air, land, maritime, and cyberspace operations, CO. Space operations are conducted in all domains with terrestrial and sea-based platforms, aboard spacelift vehicles, via persistent on-orbit constellations, and across the electromagnetic spectrum, EMS. That said, in 2017, Secretary of the Air Force Heather Wilson told Congress that space no longer is just an enabler and force enhancer for United States military operations. It is a warfighting domain just like air, land, and sea. In 2018, Air Force Chief of Staff General David Goldfein doubled down in stating it was time for us as a service, regardless of specialty badge, to embrace space superiority with the same passion and sense of ownership as we apply to air superiority today. He went on to exclaim, "I believe we're going to be fighting from space in a matter of years, and we are the service that must lead joint warfighting in this new contested domain. This is what the nation demands." To come full circle, General LeMay's 1946 Research and Development Corporation study concluded that we can see no more clearly all the utility and implications of the spaceships than the Wright brothers could see fleets of B-29s bombing Japan and air transports circling the globe. Indeed, for the last 70 years, our ability to maneuver to and through space has presented unlimited potential for prosperity and security, making continued Air Force dominance of the space domain a national imperative.